In this video, I'll be demonstrating the setting of the Microstop countersink for installing flush rivets. First thing you want to do is obtain a piece of scrap sheet metal, the same thickness as the material that you're going to be riveting. Clamp it to a nice clean flat surface and then drill some holes the same size as the rivets you're going to be installing. And here I've already got the holes drilled in this coupon, so I won't have to do that process. Then you'll install the Microstop countersink into the drill motor, and you want to make sure that the countersink cage, when it comes down to the stop, hits the stop and doesn't interfere with the chuck on the drill. I've got one here that to demonstrate what you don't want to see happening. Is where the cage actually comes down and interferes with the chuck on the drill. So you can't really tell if it's hitting the chuck on the drill or it's actually hitting the stop of the Microstop countersink. So that is not a good thing. You want to move this here Microstop countersink further out on the chuck so that you can see a gap there and ensuring that it will not interfere. So I've got this one to a rough setting by pulling down on the cage and looking across the surface of the face of the Microstop countersink. I can see the flutes of the cutter just coming above that surface. So the pilot on this cutter and the flutes are just visible above the surface. The other thing I want to make sure at this time is that I have the right size of cutter for the holes that I've just prepared. In this instance here, I've prepared holes to install 1/8 inch diameter rivets, so I've used a number 30 drill bit. So I want to ensure that my pilot on my cutter is up a number 30. So I'll take a hole gauge, drill gauge here, and I can just place it over top until I find that it does fit inside the number 30 hole. So I've got the correct size pilot for the hole that I've prepared. This will stabilize. You want to make sure that I'm going through backing material or at least 2 thicknesses of sheet metal so that the pilot will always stabilize the cutter and draw it down through the hole, making a nice concentric cut. I can hold the cage here while I pull the trigger on the drill motor, and my fingers won't get caught in that area there. That's what the cage is all about. I want the cage to sit nice and perpendicular over top of the surface of the material, and I can drive my pilot into the hole a few times just to make sure that it is actually lined up over top properly. And then I can hold the cage with my fingers, other hand, and then I'll go and pull the trigger and give it a practice countersink. Blow away the swarf. Make sure that the countersink is looking good, and I'll give it another shot in the same hole. Oh, got a little more swarf out of that one. So obviously it is cutting. And I can do it a third time even until you can see there's virtually no swarf coming up every time I pull the trigger. That means that the cutter has reached the end of its setting. At this time, you'll take a rivet, and I like to use a long rivet just so it's easier to remove and install and handle. And you can insert it into the hole that you've just countersunk. The idea now is you want to have the head of the rivet flush with the surface of the material or up to 3/1000ths of an inch above the surface of the material. I allow you 5/1000ths of an inch before I start docking you marks, but for setting up the Microstop countersink, I like to have it set to about 3/1000ths of an inch above the surface of the material. To measure that, the simplest way is to take a piece of paper and lay it beside the rivet head. Take a straight edge, lay it onto the piece of paper, and slide across, and you'll see that the straight edge hits the rivet head. So the rivet head is above the surface of the paper when I slide the straight edge across, meaning that I'll have to set the countersink to make a deeper cut. Make sure the drill's unplugged when you're adjusting this cutter. And here I placed a piece of masking tape on the cutter barrel so you can see what I'm talking about. First thing I'll do is release the locking mechanism that locks the barrel. And the barrel is free to slide back and forth inside this little groove in the body. There's a little rivet or an indentation in the cage here which allows it to slide back and forth in the body. And so make sure that is in the rivet or the indentation is sliding up inside that groove. Then if I rotate this lower portion of the cage in this clockwise direction, and it'll get a deeper cut. If I rotate it in this way here, it'll get a shallower cut. So I'm going to rotate it in here 1, 2, 3/1000ths of an inch. Now this is just a trial and error thing, so you have to do 1 or 2/1000ths of an inch at a time. I like to go about 3/1000ths of an inch at a time just so I made a positive adjustment. Now you don't have to do the locking ring back at this time here. You can leave it. Reconnect the air. Hold the cage. Remove the rivet you've just done. And I like to start off in a new hole every time after I make an adjustment. And so I'll just set it here. Same hole again. You can see virtually no swarf. So once again, I've come to the end of the stop on the cut countersink. I should install a cleco back in here and remove this clamp. I'll countersink a new one on this side over here. No swarf. And I'll go back to that very first one I did. By doing at least 3 holes like that, you can eliminate any of the inconsistencies within your pressure or other things that might cause it to be slightly inconsistent. So I'll stick the rivet in one hole, maybe stick a rivet in another hole, take my flat surface here and come across. You see it's hitting the rivet, so the rivet is above the surface of the material. Use my piece of paper, lay it beside the rivet heads, and now I can slide the paper across, and I'm still hitting it slightly there. How about this one here? Back it up. There it is there. Slide it across. Yeah, I'm still sliding it slightly here as well. So I'm going to take that Microstop countersink and I'm going to adjust it. Because I've got the protective plastic still on the sheet here, I want to make sure that I am at least 3/1000ths of an inch down. Because when I remove the plastic, the rivet will be sitting slightly higher, probably about 1/1000ths or 2/1000ths of an inch, depending on the thickness of the plastic you have. So, disconnect my air. I went 3/1000ths of an inch last time. I'm going to go another 2. 1, 2. So I've gone a total of 5/1000ths of an inch from where I started from. Back in here. Back into the very first hole that I did. I'll give it a shot. See, a little bit of swarf came out there, so I did get a cut on this one here. Yeah, did get a cut there too. Might as well do the third one. Oh, I got quite a bit of material there. Do it one more time on that one. Looks good. Take my rivet, insert it in the hole. I'm going to remove this clamp, cleco clamp there. Put the other rivet in here too. 2 rivets side by side work nice. Put the piece of paper across. Now, when I slide the straight edge across, it slides right over top of that rivet. meaning that it looks like I have gone below the thickness of the paper. If you want, at this time here, you can remove the plastic and take a look at your rivets. Make sure you push them down all the way with your finger, and then take your piece of paper and lay it beside. And you can see here that the rivet is still below the piece of paper. And when I look at the top of the rivet head, I do not see any cutting around, meaning that I haven't gone too deep. If I had gone too deep, I would see a shiny spot, a shiny area all around the circumference of the head of the rivet. And that would mean that I had gone too deep. You don't want to be too deep. You can always make the countersink deeper before riveting, but you can't make it shallower. So you're better off always leaving it a little shallow rather than too deep. The ultimate test for flushness will be after it's riveted. Once it's riveted, then you can once again check the flushness of the rivet, of the countersink that you just made, right? Some other problems that might stop you, or you might run into when you're cut countersinking using a Microstop cut countersink, one of the most common ones, is that you've placed your practice material on top of another, on your workbench or on top of another piece of scrap material, and the pilot on the cutter will hit the bench or the material below, stopping you before you actually get full depth. And before the cut countersink hits its stop, the bench is stopping you. That's probably one of the most common problems. So make sure that when you put your practice piece onto a piece of flat material, that it is deep enough, or drill it. I like to use a thick piece of plywood or something, thick enough so that making sure that my pilot will not hit the bottom of the hole and stop me before the stop on the Microstop countersink does. A free countersink is used in your drill motor as you're installing rivets to correct any slight irregularities. If you install a rivet and you find it sits too high, pull the rivet out, stick it in, take a look, see is it countersunk enough? Was it my riveting operation is why I don't have flushness? Or is it because my countersink wasn't quite deep enough? And that happens quite often. So take a standard cut countersink, stick it in your drill as you're riveting. You can easily adjust, give each countersink a slight little touch as you go along to correct for any problems that you had. When I use my cut countersink, Microstop cut countersink, I always adjust it so that it'll always be too shallow, never too deep. It'll be just right or too shallow. Because I can always correct for the too shallow using a free countersink as I'm riveting. That's all there really is to setting a Microstop cut countersink.